Yeah. Okay. I don't know if the other screen's turned on. Okay, we'll continue on talking about object-oriented programming. So we left off on Monday. We covered S3. S3 is kind of the basic object-oriented system, and the key there is that we have generic functions, and the generic functions have methods. The methods are kind of like customized versions of each of those functions that will behave differently based on the function that you give it. Okay, and that's the S3 system. And we noticed things about S3 were ad hoc, in that we could just take an object and we could change the class of the object just by saying class of the object is now data frame, or class of the object is now LM, or things like that. And when we did that, R allowed us to do that, but then the behaviors of the methods may not have been what we expected. Okay, so S4 is similar to S3 in that you still have generic functions, and the methods are kind of customized versions of those functions, except now we add some formality and rigor to the system. Okay, you're no longer allowed to just change the class of an object on the fly. And classes have formal definitions. Okay, so rather than just say, here I'm making, here's my object, my list, and I'm going to say the class of this list is now class foo, I now have to define a formal class foo with kind of all of its properties and things like that. Okay, so that's S4. And then method dispatch can be based on multiple arguments to generic functions. So in S3, it was just, it decided which function to run, which method to run based on the class of that object. Okay, and with S4, you can specify more things than just the class to decide which function to run. And then we have a special operator, the @ sign, and that allows us to extract fields from an object in S4. Okay. So we'll cover this today, and students always ask, do I need to know this for the test? So I'll say S4. I won't cover that on the midterm exam. Please don't just turn off your brain now that I've said that. But you will be responsible for knowing S3. So all of this stuff covering kind of the generic functions and the methods for S3, that stuff will be you will be responsible for. Later today we'll cover reference classes, and that will not be on the midterm. However, reference classes will make an appearance on a future homework assignment. So when that homework comes, you'll want to probably refer back to these slides on how to use reference classes as well. Okay, but reference classes themselves are built on top of S4, and so it makes sense to cover them. Okay, S4 is all the S4 object-oriented system is all in the methods package. It's always loaded when you boot up RStudio. However, R does allow for what's called batch mode, which is you run a script without even technically starting up your graphic user interface of R, and you just kind of tell the computer to run an R script. And in those cases, you might not have the methods library loaded. So if you're going to put it in a script, then you should put in the line library methods. Okay. You can figure out if something's S4. You just run is it S4, and that will return true. Or if you ask for the structure of an object, it will say it's a formal class. Formal will be like for S4. Or if you have the library prior loaded and you start up O-type, it will say S4. Okay, and then the generic and the methods, those functions, they're easy to identify because they are S4 objects. Okay, and one thing to note is that we don't have anything that's S4 in the base packages. Okay, all of the objects in base packages are S3. Okay, so if you run the command MLE, what it outputs is an MLE object, and that's going to be an S4 object-oriented system, okay? Or object-oriented, S4 system object, okay. So the output of MLE is fit, and if we ask, is it S4, it will say fit. If we ask the object type using the library prior, it will say S4. Okay. The knobs is a function, okay, that's S4. If we ask using the prior package function type on knobs, it also says S4, and it's a generic type function. Okay. You could figure out, you know, kind of some of the methods, okay? So we have a method for knobs, okay? So if we call, if we say which method would get run if we run the knobs function on the object fit, that will be the method specific for that thing, okay? We're asking R to save this output, the method, from this particular call. So again, over here we see knobs is a generic function, and when we put in the MLE object, it's going to run the MLE version, the method here. Okay, and so we can say, is that S4? And it's yes. And if we say, what's the function type of this thing? This will say it's a method versus a generic, right? So the generic is the same word that gets to be used for different object types. And then the method is the specific version of that function. Okay. And then is a function that will tell you the class of the object or the things where it inherits from, okay? So we could say, what is fit? And it's going to say the class of this object is MLE. And if we give it two arguments, we could say, is object fit of class MLE? And that will respond true. Okay, so these are just ways to see if something is of the S4 object system. Okay, so again, in S3, all we had to do was just say, you know, you create a list, and then if you wanted to make it class foo, you just say class of your object is now foo. And if you want to do something else, all you had to do is just specify the class. Okay, here with S4, you have to formally define these things. Okay, so you have to use the function setClass to define a new class of object, and then you would create a new object of that class with the function new. Okay, rather than just doing it kind of on the fly, we have to now use these formal systems. So now there's like paperwork that needs to be done regarding these things, right? So yeah, back in the day, you wanted to get married, you just say, now we're married, and maybe you'd have a ceremony. Now you have to have paperwork for the government to recognize that, right? So so S4 is just, now we're more civilized, I guess. Okay. All right, so when you define the class, you have to say, you need to give it a name, okay? And then you give it some fields, all right? So, for example, we can create a new class of object, and we're going to call this a person, okay? We'll create a person class, and the person class will just have two bits of information, the person's name and the person's age, okay? And then when we define these fields, we have to tell it what kind of data will go into each of these fields or these slots, okay? And it, you know, if you so here we'll say whenever we have a person, there's going to have two slots or two fields. One is called the name, and one's called the age. And then the type of data that goes into name is character. The type of data that goes into age will be numeric. Okay. You could also use any, and then that allows anything to go in there. Okay. And then so you give it the slots, and then you'll say the string that gives the class that it inherits from. Okay. So if it's going to inherit from another class, then you would do that right there. Okay. So for example, here we're using the function setClass. The setClass, we are defining the class person, and then the slots that it holds are the name and the age, right? So the slots, we did put the slots into a list. Okay. So we say the list, we're going to have name and age. And that's it for this one. Here we have a specific, another class. This is a class employee. Employee is a person, and the only thing that differentiates perhaps an employee from a regular person is that in our case, we're going to say employees have a boss. Okay? So here, we're going to do setClass, and we're going to call the class employee, and it says contains person, okay? Which means the slots that exist for the person class, name and age, also go into employee, okay? So the employee will have three things. It will have a name, an age, and a boss, okay? And therefore, we could define two instances of this object, right? And so now we use the function new. Okay, so before with S3, we would just kind of take a list and we would say name is Alice, age is 40, class is person, or something like that. But now we have to use setClass to be, to formally define these classes, and then we use the object new. I mean, not the object, the function new to create new instances of these things. So we've got Alice will be a person. Okay, the name is Alice, and Alice's age is 40, okay? John will be an employee, name is John, age is 20, and then the boss is Alice, okay? So notice that when we defined employee, we didn't say, we gave it the slot boss is equal to person, which means the thing that goes into boss has to be a person class object, right? It's not just a character string, but this is a person class object for John here. So this is how we could define classes and so on. So this is just a simple example, but we could expand this much more. Okay, and so if we want to extract the value in Alice that corresponds to her age, we would use the @ sign. So this feels strange or is new because we're used to using the $sign, right? So whenever you have the list, a named list, you generally use a $sign, but for S4 classes, we use the @ sign. Okay, or you could use slot, okay, and you could say what is stored in the boss slot for John, and then it will say what we have there is an object of class person, and then within that person we have the name Alice and the age 40. Okay, here we could it says if an S4 object contains an S3 class or a base type, it will have a special .data slot. So in this case here, we have slots for a minimum and a maximum, but it also itself contains a numeric thing, okay? And so when we create a new instance of this thing, we populate the slots, min and max, but then we also have the values 1 through 10, and that gets stored in the slot.data. Okay, here if we can ask for the structure of Alice, okay, and it will say we've got a formal class person with 2 slots with this is the structure. And then if we wanted to try to kind of just mess around with this, okay, so if we say, you know what, we're going to change the definition of person, okay, to say it's got a name, an age, and a city, okay, and now, so we haven't modified Alice, and so now when we try to look at Alice and look at its structure, it now produces an error because we've modified the definition, and so Alice no longer fits the structure that is defined by the class, that class definition. Okay, so that's going to produce an error now. Okay. All right. So here, if we want to take functions and create methods and generics, okay, we can take an existing function. So we have an existing function called union, okay, and union works with kind of vectors, and it tells you you mix the vectors together and it gives you something together, all right? And so here we're going to take the regular old union function and turn it into a generic, okay? So all we had to do that is just use the command set generic on union, and then it obeys us. And then we say, then we create a method, okay, and we say set method on union, and it's now going to accept these 2 things, x and y. X has to be a data frame and y has to be a data frame. And then when we do this, the specific version of this method is now going to be a function, and this is the command that it uses. So it says, you know, bind it by rows, and then just kind of keep what is the unique rows. So if there's duplicates between x and y, those will get eliminated via the unique command. Okay. And so now we have a generic function union. Union will still work the normal way for regular old vectors, but then if we give it 2 data frames, R will recognize, okay, now I need to call the method that I've created for when the inputs are data frames. Normally, if you ask union on data frames, it's gonna complain. Okay. If you want to start from scratch and make your own generic, then you use the command standard generic, right? And this is kind of like use method back in S3. So at S3 we knew functions were generics if we kind of looked at the definition of the function, and if all we see is use method. Okay, use method or standard generic in this case just indicates to R that this is a generic function, and that when you get objects of a certain type, we've got to call the class that be the method that applies to that class of object. Okay, so that covers S4, and again, it's just kind of the more formal system for object-oriented stuff, more formal than S3. But now we can talk reference classes. Okay, you know what, I think I made some. Let's go ahead. Give me a second. Okay, so the key difference with reference classes versus the other object-oriented systems is that reference classes the methods belong to the objects. Okay, so if you've done other object-oriented programming in R, you're probably accustomed to the kind of object-oriented system that reference class implements. Okay, so with reference classes, the methods do not belong to the functions, but the methods belong to the class or the object themselves. Right? So let me just kind of, so with S3, kind of the analogy here is you have this generic verb. Your function would be like the generic verb swing, okay? And depending on the object I give you, and I give you the command swing, your motion will be different, right? If I give you a baseball bat and I say swing, you're gonna swing it like a baseball bat. If I give you a golf club and I say swing, you're gonna, swing like it's a golf club, right? And then if I give you something, just a random thing like a book, and I tell you swing, your brain will say, okay, well, I got to figure something out to do with the swing, and you'll do some kind of default generic thing, right? So that would be kind of like the S3 system, where you have the generic verb, and then it takes on a specific look depending on the object I give you. Okay. The other system is now you have different objects, and those objects have defined actions. Okay, so I could give you a phone, and it will have a method called turn on. Okay, and that will look like pushing the button here. Okay, or I will give you a flashlight, and it will have a method turn on, and that's going to be push the button on the flashlight or something like that. Okay, and so based on depending on what you have, so the object flashlight will have probably only a few methods associated with it, right? Turn on, turn off, change battery, point. I don't know. Okay, and other than that, these are only the only actions that you can do to the flashlight. These are the only methods that are allowed for the flashlight. Okay, and depending on other objects, the object will define kind of the list of actions that are allowed. Okay, and that's what we have with reference class. The other big thing about reference class is that they do not have copy on modify semantics, right? So what that means in R, normally when you make a change to something, or you make a copy of it, not make a copy, but like if you say, let's say you have the object x, right? X is some vector 1 through 5 or something like that. And then you say y is equal to x. Then in R, what that normally does is that y is now also the vector 1 through 5, but they are copies, okay? And so if you modify x, it doesn't affect y. With reference class, it doesn't work that way anymore, okay? When you modify, if you say y is equal to x, and then you modify x, that also affects y, okay? And that's very different from what we might be used to when using R, okay? They're still just actually S4 classes. They are inside an environment. So each reference class is basically its own little environment with its own variables and things that it allows itself to keep track of here. Okay. So when we create a new reference class object, we use the function called setReferenceClass. Okay. And when we do setReferenceClass, we give it a name, and then and if we want a new instance of this thing, we would say, okay, account $new. We use the new method for that thing, and it says, okay, now we've created a reference class object of class account. Okay, so what we do here is we would to create an account reference class object. We also define fields, or just like slots, okay? And so here we're going to create an object, we're going to create a reference class called account, and the account contains one field called balance. Okay, so we say fields is a list, and the balance is numeric. So this part looks a lot like S4 stuff, except instead of slots, they're called fields. I'm just going back. Reference classes makes the most sense to use things for stateful objects, meaning these objects kind of change over time, and you need to kind of keep track of these things, right? And so so here, kind of a bank account thing kind of makes sense, all right? And so here I can say we're going to create a new account. The new account is A, and so we say accounts $new. So that's the method for creating a new instance of an account, and we're going to set balance equal to 100. So we say, okay, what's the balance? A $ balance. So we access the fields using the $. So this is something we're probably used to now. A $ balance is 100, okay? And then if I want to change that, I say, okay, we're going to say A $ balance. We're going to store the number 200 in there, and we get A balance 200. No problem. All right, and this is again the key difference here is that the objects are mutable. So here I'm going to say take A and put that into B. Okay, so we ask. So here we left off with the balance in A to be 200, right? So here we're going to say A is now B. We're going to do B. The balance in B is 200. Okay. And then we go back to A and we say, all right, change the balance in A to 0. Okay. And then, so the balance in A is now 0. And then when I ask, okay, what is the balance in B? It is now 0, right? Because B is pointing to A. It's not, B is not, when we did B is equal to A here, basically we are just saying, we're just creating a name, B, which really points to the original object A. Okay, everything else in R, when you do B is equal to A, it generally creates a copy of it, and when you modify A, it doesn't affect B, and when you modify B, it doesn't affect A. But here, when we say B is equal to A with a reference class object, B is just a name that points to A. So when we modify A and we ask, look the thing up in B, it points back to that thing in A, and we see that it has changed. Okay, and so this is something that's, I guess, people are not used to. Okay, at least if you're coming from R, right? If you come from Python, then this makes sense. But if you're coming from R, it doesn't. So here, if we wanted to have that copy semantics, right, that we're used to, then we would say A, and we would use the method copy. Okay, and we're going to throw this into C. Okay, so we leave off, right? The balance in A is now 0, and we check on B, and the balance there is also 0. Okay, and so here we can create a copy using $copy, using the copy method. And so C, the balance in C is 0. We can modify the balance in A, and now we have two separate things. Okay, so C is now just a copy of A when we created the copy. After I've modified A, and then I check over on C, C doesn't actually point to A. C is its own thing that was just copied when we copied A. And so here, the balance in C is still 0, even though I just modified the balance in A to be 100. Okay, does that make sense? What's going on? All right, and if I did B $ balance, what would I have? I would have 100, right? Because B is not a copy, it's a pointer pointing back to A. Okay, so that's the kind of just the fields that you have, and then again, we might want to have functions now. Okay, and so the functions belong to the object. So here, I'm sorry, these methods belong to the object. So here we're going to create two methods, one called withdraw and one called deposit. And so here we still have an account. The only field in account is a balance, which is a numeric field. And then we create a method, okay? So the method, so we have fields and methods. Methods is a list of functions, okay? Methods is a list of functions. And here I've got two functions. Withdraw is a function and deposit is a function. All right, and notice here, I'm using super assignment, okay? This is one of the few times where we actually do want super assignment in our function, okay? Because what you have to imagine is that the reference class object is its own environment, okay? So within, you have your global environment, and then the reference class object is its own environment. Its own environment that keeps its own balance variable, okay? And that way, when you did B is equal to A, B just pointed back to that environment. When we said C is a copy of A, we created a copy of that environment. So we have a balance variable over here in A, and then now over here with the copy, we have a balance variable in C. And that way, in these two separate environments, when I change the variable in A, it doesn't affect the balance variable in C, okay? And now that we have functions, okay, within this environment, I've got the balance variable, and then within that environment, I have two functions, withdraw and deposit. So you have to think of this now mini environment where I've got three things. I've got the balance variable, which is 100 or 0, whatever number it is, and then I've got the function withdraw and the function deposit. Okay? And so if I execute the withdraw function, whenever you execute a function, it creates its own execution environment where the variables exist and then they disappear, right? But what we want to do is we want that function to modify the balance variable that's inside our reference class environment. Can you picture what I'm talking about here? Okay, so that's why I want the super assignment here, because when I run that withdraw function that exists inside this reference class environment, I want that withdraw function to actually modify the balance in here, okay? So it's very important that when you define these functions, you are using names of the fields that exist in here, right? If you just say super assignment to y or something, and you don't have y as a field in here, then it's going to keep climbing up the scopes until it finds that thing y. Okay, but here it makes sense because we don't want the value balance to just exist in the execution environment and then disappear. So here we're going to say when you run this method, we're going to change the balance. We're going to take the balance, subtract x from it, and return store that back into balance inside the reference class environment. Okay, and then if we're going to deposit, then it's a function of x. We add x to the balance. So here, this is a reference class, where we have one field and then two methods. Okay, and so here we're going to create a new account A with a balance of 100. And then I do deposit 100, and then if I check on the balance, it's now 200. Okay. So that's what we have. So again, a reference class is like its own separate environment that exists for that object. Okay. And so when we create other instances of these, it creates new environments that all have their own functions and own list of variables or list of fields stored in that environment. Okay. Let's let me pull this up here. Okay, so here I'm going to create A. So we have A is this, A $ balance, okay, is 100. And then we can do A $ deposit, and we'll add 100, okay? And then so we can say A $ balance is this, right? Okay, so what if I did B points to A, okay? And then I said B $ deposit 300, okay? So the balance in B will be 500. What is the balance in A? It's also 500, okay? Because the way we did this, these B points back to A here, okay? On the other hand, if we wanted the copy thing, we would have to do something like, okay, and so the balance in D is 500. If I do D withdraw 250, okay, is that, and if I ask what's the balance over here, it's still 500. What's the balance over here? It's that, okay? So, and again, you know, whatever we do to A or B, those are kind of tied to each other. Okay, so that's what we have. So these are our methods, okay? Just like other objects, we can have the object's inherent properties from another object. So here we've got we can add the argument contains, okay? And so this will be a way to say this inherits everything from that, okay? So here we're going to create a reference class called noOverdraft, okay? And noOverdraft contains an account. So if we go back to the account reference class, that means it's got the balance and methods withdraw and deposit, okay? And with noOverdraft, it contains the account, so it has the balance, it's got the withdraw, and it's got the deposit method. And what we do is when we define our methods, we're going to create a new withdraw method, okay? This withdraw method will then override the other withdraw method that exists in account. And so here, withdraw is a function where it just has a check where if you're trying to withdraw X and the balance is smaller than X, it's going to kick back an error that says not enough money, okay? Otherwise, subtract X from the balance. So here I can do, you know, right now, if I ask for the balance in A, it's 500, and if I say run the command, run the function withdraw 600, A does so, and we have a balance of minus 100. Okay. And so here we can create, we'll create a new instance of noOverdraft, and we can see this thing in action. So we'll create an account for John. John has a balance of 50. We can deposit 50, okay? So we did not give it the deposit method when we defined it, but because it inherits from account, this method does exist, right? So so if we ask for the balance here, it's 150, and then if we ask for it to withdraw 200, it gives us an error. It says not enough money, so it doesn't execute that. Okay, so all of our reference class objects, the ultimate parent that it inherits from is the environment reference class. Okay, the environment reference class comes with its own kind of set of methods, such as copy and field and export and things like that. So, you know, I didn't have to create a copy method to be able to use that copy function to create a copy of the environment. Okay, and so so this is what we have, and you can always look at help on set reference class to kind of see how all this stuff works here. As soon as so, you know, fields with a reference class. Okay. Okay, so we'll just end there. There is sorry, that's nothing actually on the midterm exam. So as far as method dispatch goes, it's easy because the methods themselves belong to the objects there. Okay. All right. So we'll end here, and then we'll see you guys on Friday, and I hope everything's going well.